Welcome back. Today I will see some basic question of linear algebra. Today's goal of this lecture is I will see some question which had come different type of exam. First goal. Our goal of this lecture is if for any matrix if row sum with the lambda, then obviously lambda be an eigenvalue of this matrix. Also, if column sum be lambda, then lambda be the eigenvalue of this matrix. We all of us know this part. And I will say one question which had come CSIR net exam based on this row sum and column sum. Okay. Our next goal is I will say when a non-homogeneous system of equation has a solution. All of us know if rank of A equal to rank of augmented matrix, then always there exists a solution. Then I will say when a non-homogeneous equation has a solution, has no solution, has infinite number of solution, has unique solution. We all of us know when this solution exists, when there exists no solution. But I will see some question based on this property. This is our goal of today's lecture. Now let's see first question which depends on this topic. First question which had come CSIR net 2021 exam. The question is A and B be n cross n matrices. Suppose that the sum of elements in any row of the matrix A is 2 and sum of elements in any column of the matrix B is 2. Then which of the following matrices are necessarily singular? Option 1, identity minus half BA transpose. Option 2, identity minus half AB. Option 3, identity minus 1 over 4 AB. Option 4, identity minus 1 over 4 BA transpose. Which of the following matrices is necessarily singular? Here A and B n cross n matrices, okay, and sum of each row of A is 2. That means obviously 2 be the eigenvalue of A and sum of each column of the matrix B is 2. So 2 is eigenvalue of B. Okay. Here the question, here AB, here BA transpose, here AB and BA transpose. In my hand has A and B has at least one eigenvalue B2. But we cannot tell about the eigenvalue of the matrix AB. These product AB matrices have eigenvalue 4 when they have common eigenvector. But we don't know about the eigenvector of the matrix A and B. So we cannot tell about the eigenvalue of the matrix AB. Since A has at least one eigenvalue 2, that means we can tell AB equal to 2 times B, and since each column sum of the matrix B is 2, so obviously we can tell B transpose V equal to 2V. Therefore, Here I have got AB equal to 2B and here I have got B transpose V equal to 2B. Therefore, AB transpose V equal to, obviously this would be 4V. Okay. Here about the BA transpose. So, since here AB transpose, just take transpose again, then this would be BA transpose, and we all of us know if AB transpose has a eigenvalue 4, then obviously BA transpose also has a eigenvalue 4. Now let's see the option. Which of the following matrices is necessarily singular? We all of us know a matrix be singular when eigenvalue be 0. When there exists a eigenvalue with 0 for this option, notice I have got BA transpose has eigenvalue 4. So, here since identity, that means obviously all eigenvalue here 1. Here 1 over half times 4, this would be 2, so this cannot be 0. Also we cannot tell about this part, only we can tell about BA transpose. So since BA transpose has eigenvalue 4, here also 1 over 4, that means this value would be 1 and eigenvalue of identity always would be 1. So 1 minus 1 equal to 0. Therefore, obviously, identity minus 1 over 4 BA transpose has a eigenvalue 0. So, fourth option is a right option. Since this matrix has eigenvalue 0, so obviously this matrix be singular. Are you getting? Oh well. Now I will see one question which depend on non-homogeneous system of equation. When a system of equation has a solution, this question had come 2019 December CSIR NET exam. The question is, consider this matrix, then the system of linear equation x equal to y has a solution only for y equal to x00 where x belongs to real number. Option 2, only for y equal to 0y0 where y belongs to real number. Option 3, only for y equal to 0yz where yz belongs to real number. Option 4, for all y belongs to Earth. The problem of system of non-homogeneous equation. We all of us know system of non-homogeneous equation has a solution if and only if rank of A equal to rank of augmented matrices. First, recall my previous video. If dimension of row space equal to R, then obviously dimension of null space would be n minus R. This is the null space and this is the row space. Here, we all of us know null space be the orthogonal complement of row space. That means here all vector perpendicular to row space. Therefore, dimension of row space R and dimension of null space n minus R, every vector in Rn can be split into component of row space and component of null space. Notice this is Rn and this is Rm. Every vector here written as component of row space and component of null space. This is the null space and this is the row space. See the picture. My all viewers know this topic clearly because I have discussed this topic in my previous lecture. And null space component goes to 0 and row space component goes to AXR, which is equal to X equal to B component. Therefore, every vector B in the column space comes only from row space. This is the picture, and this is the null space of A transpose, because this is the column space, and null space of A transpose actually all vectors that are orthogonal to these columns. Just recall the solution X equal to B, uniqueness always imply existence. That means uniqueness implies existence and existence imply uniqueness, and that imply actually the matrix A is invertible. In opposite way, existence always imply uniqueness. That means here there exists solution for all B. If there exists solution for all B, then obviously in the matrix A there exists no free variable in the null space. Null space contain only zero vector. This is the opposite direction. Existence always imply uniqueness. That means X equal to B, there exists no zeros in the rows. That means there are n pivots and no free variable, and the null space contain only zero vector. Our question depends on this concept. When there exists no free variable, only n pivots, that means determinant of this matrix be non-zero, then always there exists solution for every B in the column space, and then null space of this matrix contain only zero vector. This concept is depend on today's question. Okay, now let's see the solution. This is the problem of system of non-homogeneous equation. We all of us know system of non-homogeneous equation has a solution if and only if rank of A equal to rank of augmented matrices. First solve the equation oneself. Notice since here 3 pivot, that means obviously rank of this matrix and rank of augmented matrix are same. So obviously there exists a solution, and this solution is unique solution. Just recall, I have discussed this part in my previous video elaborately. We all of us know a system of equation has a solution when rank of the matrix is equal to rank of the augmented matrix. If you don't see my previous video about when system of equation has a solution, when not solution, when there exists unique solution, when there exists infinite solution, I have given the link in my description box. If you don't see my previous video, at first I will highly recommend you see the link in my description box. Then at first see my previous video. Then today's video would be so easy. By this method, by this operation, we can tell exists always unique solution. Here in the question has given the solution exists for which y. For this, I will apply determinant. Notice here determinant of the matrix is 9, so this is not equal to 0. That means obviously A inverse exists. So the solution Ax equal to y, since A inverse exists, so we can tell this as x equal to A inverse y. Okay, that means there exists a solution for all y. So next come back question. Here only for this y, here only for this y, here only for this y. And here notice option 4 has indicate for all y belongs to R3. This is true option because determinant of this matrix is not equal to 0. I hope my all viewers have understood this question clearly. Now I will say another system of linear equation which had come CSIR NET February 2022 exam. The example is, consider the system of equation 2x plus ky equal to 2 minus k, kx plus 2y equal to k, ky plus kz equal to k minus 1. Here 3 unknown and 1 real parameter k. Here the question, for which value of k is the system of linear equation is consistent? Option 1, 1. Option 2, minus 1. Option 3, 2. Option 4, minus 2. Here we have to check for which value of k the system of linear equation be consistent. We all of us know when system of linear equation be consistent. At first, just recall, I have discussed this topic elaborately in my previous video and I have given these links in my description box. So if you don't see my previous video, at first see the previous video. Then this concept would be so clear. The system of linear equation Ax equal to b, here column of the matrix are A1, A2 up to n. Here Ax equal to b means x1 A1 plus x2 A2 up to xn An equal to b. And the system of linear equation Ax equal to b has a solution if this vector b is linearly independent column of the matrix A. That means the vector b belongs to span of A1, A2 up to n, and the equation Ax equal to b has a solution if, we all of us know, if b lies in the column space of the matrix A. That means here this b when lies in the column space of the matrix A, then this equation has a solution. That means then the equation would be consistent when this b lies in the column space of the matrix A. I hope my all viewers have understood what is the b and when the solution exists. B is nothing but B is linear combination of the column of matrix where each column is denoted as A1, A2 up to An. Here this is the system of linear equation Ax equal to b, where the matrix would be reduces to K0, notice the equation, K2 0, 0 Kk, and the value of the b is 2 minus k, Kk minus 1, and the matrix would be consistent. This is the augmented matrix. We all of us know if rank of this matrix means this part is equal to rank of this augmented matrix. Here augmented matrix means this part. We all of us know rank means just how many linearly independent vector exist in the matrix. But here notice the matrix is square matrix. So we can check linearly independent by determinant. If determinant of this matrix is non-zero, that means we can tell there exists always be solution for all k. That means actually there exists unique solution. We all of us know this part I have discussed elaborately in my previous video. I have given this link if you don't see my video. That means we have to check determinant of this matrix. Notice the determinant. Here determinant is 2 times 2k minus k times k square, which is equal to actually 4k minus k cube, and we can write this as k times 4 minus k square, which is equal to 2 minus k 2 times k times 2 minus k 2 times k. And obviously when k not equal to 0, 2 minus 2, then this value always be not equal to 0. That means determinant of a not equal to 0 when k not 0, 2 and minus 2. It does not belongs to 0, 2 minus 2. Then always the matrix A be invertible. That means then always unique solution exists without this k. Are you getting? So by this solution we can tell when the linear system of equation consistent, we can tell this 1 and minus 1 always would be consistent, because I have got when k does not belongs to 0, 2 minus 2, then always there exists a unique solution. So obviously this system of equation be consistent and there exists unique solution. Now I will check for this value 2 and minus 2. Just put the value k here, then the matrix would be reduces 2 to 0, 2 to 0, here 2, 0 to 1. Okay, and notice these two row are here linearly dependent. That means rank of these matrices would be 2, but rank of augmented matrix would be 3. That means these two rank not same. So for the value k equal to 2, there exists no solution. So this system of equation be inconsistent. Are you getting the method? Similarly, if you put the value k equal to minus 2, then you will see similarly there exists no solution. That means the system is inconsistent. That means only option 1 and option 2 is a right option. I hope my all viewers have understood how we have to find when a linear system of equation be consistent or not. Okay? Well, I will stop here. In my next video, I will discuss this topic when a system of linear equation be unique solution exists, when infinitely many solution exist, when no solution exists. I will discuss this part elaborately in my next video. But at first, again I will tell you, if you don't see my previous video, please see the previous video. Okay? See you soon. Stay safe and stay positive always.